You run your finger along the joint where two stones meet. Nothing, no gap, no mortar, no sliver of daylight from the far side. The seam between these two blocks is so tight that you cannot slide a razor blade into it. You cannot slide a sheet of paper into it. In places, you cannot even find the seam at all, not until your fingernail snags the faint hairline where one stone ends and the next begins. Now step back and look at what you are touching. Each of these blocks weighs more than a loaded truck. Some weigh more than 100 tons. They are not bricks. They are not poured concrete. They are single pieces of solid rock, quarried and shaped and lifted and fitted together so cleanly that they have not shifted through 5 centuries of earthquakes that cracked and toppled the Spanish buildings raised right beside them, and no one alive can tell you, with certainty, exactly how it was done. This wall is real. You can stand in front of it today, in the hills above Cusco, in Peru, at a place called Sacsayhuaman. The stones bulge and curve and interlock like puzzle pieces, cut by a machine that should not exist, and it is not the only place. In Egypt, there are boxes carved from single blocks of granite, their inside corners crisp and square, their walls flat to within a fraction of a millimeter. In Bolivia, at a ruin called Puma Punku, there are blocks of hard volcanic stone cut with grooves so straight and so fine that they look milled, drilled, machined, dropped into the dirt by a workshop that left no other trace. How? That is the question that has launched 1,000 theories. And one of those theories is stranger and more seductive than all the rest. Sound. The idea that your ancestors did not carve these stones at all, that they sang them into shape. To understand why a serious person would even entertain such a thing, you first have to understand the problem. And to understand the problem, you have to understand stone. Pick up a kitchen knife and you can cut wood, because wood is soft and your steel is hard. That is all hardness really means. It is a material's resistance to being scratched by another material. Steel scratches wood. Steel scratches copper. But granite is not wood. Granite is a mob of interlocking crystals, quartz and feldspar and mica, fused together under crushing pressure deep inside the earth. Quartz is almost as hard as steel itself. So when you drag a copper tool across granite, the granite does not give. The copper does. The metal wears away to a stub long before the stone surrenders anything at all. Now remember when these stones were cut. The hardest of the Egyptian granite work is old, not medieval old, not Roman old. Some of it predates the first Egyptian dynasty entirely. This is work done before iron tools were common, before the wheel had reached half the world, by people we are told had nothing harder than copper, stone hammers, and sand. So here is the whole puzzle in a single sentence. How do you cut the hardest stone on earth with metal softer than the stone, and leave behind corners sharper than the tools that supposedly made them? That is the door. And a man named Christopher Dunn walked straight through it. Dunn is not an archaeologist. He is a craftsman, a machinist. A man who spent his working life cutting metal on industrial machines, watching how hard materials behave under real tools. And when he looked at the granite of Egypt, he did not see the work of hammers. He saw the work of machines. In his books, he argues that the flatness of these surfaces, the squareness of the corners, the sheer speed at which all that granite must have been removed, points to tools and methods far beyond anything a history book describes. Lost tools. Lost knowledge, a technology so completely erased that it left behind only its fingerprints pressed into solid rock. And one of those fingerprints sits in a museum, and it has puzzled people for more than 100 years. In the 1880s, an English archaeologist named Flinders Petrie, the man who practically invented the careful, measured study of ancient Egypt, was sorting through fragments at Giza when he found pieces of drilled granite. Cores. The leftover plugs of stone that come out of the middle when you bore a circular hole. And around these cores ran a spiral groove, a smooth helix scored into the rock, as if the drill had sliced downward through solid granite the way a corkscrew sinks into a cork. Petrie was baffled. To cut a groove like that, he reasoned, the drill would have to be biting into the granite with enormous force, far faster than he believed any ancient method could possibly manage. A century later, Christopher Dunn looked at the same cores and reached a bolder conclusion. Only one thing, he argued, could leave marks like these. Not muscle, not patience. Something that vibrated, something powered, and that carries us at last to the strangest idea of all. What if the power was sound? Here is the part that makes this theory so hard to wave away. Sonic drilling is real. It is not fantasy, and it is not fringe. Right now, in mining and construction, there are drills that work not by brute rotation, but by vibration. You take a drill head, and instead of simply spinning it, you shake it, thousands of times every second, at exactly the right frequency. The bit barely needs to turn. The vibration itself shatters and powders the material in front of it, and the drill sinks through rock far faster, and with far less effort than an ordinary one. Engineers use it today. Space agencies have designed ultrasonic drills to bore into the rock of other planets, precisely because high-frequency vibration does the cutting that muscle alone cannot. So the proponents ask a simple, dangerous question. If we can drill stone with sound today, why couldn't they? And then they start pointing at things. They point at the sceptre, a long straight staff with a forked bottom end that appears again and again in Egyptian art, gripped in the hands of gods and pharaohs, a symbol of power and dominion. Look at it, they say. A long rod ending in a two-pronged fork. Doesn't it look like a tuning fork? Doesn't it look like a tool? They point at carvings they claim show fork-shaped objects joined by wires, and they repeat a story, passed hand to hand across the internet for decades, of a researcher who supposedly slipped through a locked door into an Egyptian storeroom and found it stacked with hundreds of giant metal tuning forks, some of them 8 feet tall, that hummed for minutes when you plucked the wire stretched between their prongs. It is a thrilling story, and you should notice something about it. The man who first told that story, in an email in the 1990s, ended it by admitting he had no way of verifying any of it. No photographs, no catalog numbers, no museum that will confirm the forks were ever there. The carving of the so-called two tuning forks is religious imagery that Egyptologists read as something else entirely. And the sceptre had a clear, documented meaning to the people who carried it, and that meaning was authority, not engineering. This is where the theory of singing stones begins to come apart in your hands. Not because the idea of sonic drilling is impossible, but because impossible was never the test. The test is evidence, and when you go looking for proof that ancient Egyptians actually built and operated sonic drills, you find symbols reinterpreted, anecdotes no one can trace, and a single phrase repeated over and over. Perhaps, maybe, it could be. There is also a quieter problem, one the spectacle tends to drown out. The boldest version of this theory is not just sonic drilling, but acoustic levitation, the claim that sound waves lifted 100-ton blocks gently into the air. Acoustic levitation is also real, and you can watch it happen in a laboratory right now. But watch closely what it lifts. A single droplet of water, a tiny bead of polystyrene foam, a few millimeters across, trembling in a focused beam of sound. To suspend a grain of sand against gravity, using nothing but sound, is a genuine and astonishing scientific feat. To lift a stone that weighs as much as a blue whale is not a harder version of the same trick. It is a different universe, one our physics does not contain. So if it wasn't lost machines, and it wasn't singing the rock up into the sky, then what is the answer? And why is the real answer the part of this story that almost no one ever tells? The real answer was not found by arguing online. It was found by a man who spent years in a workshop trying to do it with his own 2 hands. His name is Denny Stocks, and he is an experimental archaeologist, which means he tests ancient techniques by actually performing them, using only the materials people of the time would have had. Stocks took a copper tube, he took sand, ordinary quartz sand, and he set out to drill granite. The secret is the sand. The copper tube on its own is useless against granite, exactly as the theorists insist, but the copper was never supposed to be the cutting edge. You feed sand under the turning tube, and the hard quartz grains become trapped between the soft copper and the hard stone, and it is the sand that does the cutting, dozens of tiny hard crystals dragged in a circle, grinding the granite away grain by grain. The copper is only the thing that holds the sand and turns it. And as the tube slowly sinks, it leaves a core standing in the center, with a spiral groove cut into it, because the loose sand bites downward in a slow descending spiral, exactly like the marks Petrie found. The very fingerprint that was supposed to prove a lost machine turns out to be the signature of copper, sand, water, and time. And here is the twist, the part that should quietly change how you see all of it. The mystery was never really the tools, it was the patience. Go to the Aswan quarry in southern Egypt, and you can see it with your own eyes. There, lying in the bedrock where it was abandoned thousands of years ago, is a colossal obelisk, still joined to the mountain it was being carved out of. Finished, it would have weighed more than 1,000 tons. They never raised it, because as they worked, a crack opened in the stone, and the entire project was given up. But because it was abandoned in the middle of the work, it became something priceless. It is the labor itself, frozen in the act. And all around it, sunk down into the granite in long, narrow trenches, you can read exactly how it was really being done, and you can still find the tools they used to do it. Balls of a stone called dolerite, harder than the granite itself, pounded against the rock by hand to bruise and crush it away. Blow after blow after blow, for weeks, for months, for years. There were no machines in that quarry. There was something we find far harder to imagine than any lost technology. There were thousands of human beings, organized, skilled, and almost incomprehensibly patient, willing to spend years of their lives grinding a mountain down with stones and sand, because the thing they were making mattered more to them than the time it cost. That, in the end, is the part you find difficult to believe. Not that they had a secret, that they had a patience you have lost. But before you close the door on sound completely, there is one last thread, and this one does not unravel. Because while there is no good evidence that anyone cut stone with sound, there is real and serious evidence that some of these people understood sound in ways we are only now rediscovering. The study has a name. It is called Archaeoacoustics, and it is carried out by genuine researchers measuring genuine buildings. And they keep finding the same uncanny thing. Certain ancient chambers seem tuned. Beneath the ground on the island of Malta, inside a temple cut entirely out of the living rock, and called the Hypogeum, there is a small carved room that resonates powerfully at a frequency of around 110 Hz. That is close to the pitch of a low male voice. It is also a frequency that has been shown to shift activity in the listening human brain, a frequency that can make a space feel charged, solemn, alive. Stand in the right spot in that room and let your voice drop, and the whole chamber answers you. That is the truth that survives all of this. Not that your ancestors carved granite with a song, but that they built rooms designed to sing back. They understood that a space could be shaped to do something to the mind of the person standing inside it, and they pressed that understanding into stone. And then the understanding was lost, and we walked through those rooms for centuries without ever hearing what they were for. So, which is the real miracle? The fantasy of a machine that hums stone into shape and was conveniently lost without a single surviving part, or the reality that ordinary people, with copper and sand and a patience you can barely picture, reshaped mountains, and that some of them learned to tune a room to the resonance of the human body, and we are only now, with all our instruments, beginning to notice what they did. You came here looking for a lost technology, a button someone forgot how to press. But run your finger along that seam one more time. Feel how there is no gap, no daylight, nothing your razor blade could ever slip into. That seam was not left by a machine you have forgotten. It was made by hands like yours, by people who were not simpler than you, who were not waiting on aliens or magic, who simply decided that something was worth doing slowly and perfectly, and who had the patience to see it all the way through. The technology was never lost. You were only looking for it in the wrong place. It was never in the tools. It was in them.